Hi there, this is Neil Bolger at A2 Efficiency, and in this video, I'm going to share a bit about proper plumbing and how to evaluate heat pump water heaters in building design. This is all going to be specifically for how to put a heat pump water heater into EnergyPlus, just given some of the challenges that can face energy modelers when trying to configure this system. This is a video that is just in support of the heat pump water heater market and sharing some of the best practices we've learned along the way and the struggles in trying to understand how we translate an intention around an efficiency measure like a heat pump water heater into a design, how that design varies, and then into all the inputs that we have to assume inside the software just to see how it's going to pencil for different projects. So hopefully this can help you stand on our shoulders and scale this technology even faster. All right, so this is going to be a quick tutorial, and we're also going to, in this, share an EnergyPlus file and share this simplified pre-simulation input tool we built to help ourselves build up energy models of heat pump water heaters. All right, so it's kind of to answer the question, how can you evaluate a heat pump water heater in early design phases with limited information? All right, you might have a building. Everyone's talking about heat pump water heaters, but still someone says, well, what's the savings? What's the energy cost savings for this location or this application? And what if we have a lot of storage or a little storage or a more efficient heat pump or a less efficient one? And it's up to you, the modeler, to work with that team to really bring some numbers quickly to the table. And you may not have a ton of information aside from the intent to look at it. Maybe you do have some sizes of a tank, of a water heater, but what if you have none of those things? How are you going to start from nothing and come up with an answer? So what are we talking about? Heat pump water heaters, right? We're talking about a tank of water and a air to water heat pump device. In this configuration, we're showing it as like an outdoor split, but they certainly sell these devices where the compressor and all the coils sit on top of the tank. And the way we're going to look at this system in the demo today is with once through water. So you can also have lots of configurations where you could have a recirculation loop, another tank that's maintaining the recirculation loop, maybe called a swing tank. You can model those configurations as well, but just for simplicity, we're going to start with this configuration because this alone in EnergyPlus has a lot of mechanics just to like make all these little pipe connections work. But the way we're going to evaluate this would be the same as if you did evaluate a smaller one that had the compressor right on top. And we'll talk a little bit about how you could even put it inside the building and pull air from a room, not just from outside. Okay, but this configuration generally is in smaller commercial buildings, right? Maybe some hot water sinks in a warehouse office or in like low-rise multifamily or apartment buildings. Think like 10 units or less. Maybe they're sharing some water heaters, or they each might have their own. But either way, kind of the same single family style, but put in different small applications. All right, so the big problem. This is the big problem as I could frame it the best. So EnergyPlus heat pump water heater is made up of several components configured in just the right way. So you have to get them all right, and you also have to size them all. So the next piece, right, it requires inputs to be specifically defined. It has to match the climate, it has to match the peak load for hot water, it has to match the operating conditions. Where is it in the building? Is it pulling room air? Is it pulling outside air? And then often the whole system includes a backup heating device sometimes or an additional electric heating device, and that also needs to be sized. Well, all of these sizes and all of these relationships to the sum of all the hot water flows, the climate that it's in, the capacity of the heat pump, the capacity of the backup heater, the tank itself are all inputs that the modeler has to specify. There is almost no auto sizing maybe outside of like one field out of 50 for these devices. So it lends itself to wanting an engineered solution to understand the energy benefits, which would be great if we always had a fully engineered solution, though very often we have a half engineered solution or an idea of a measure that would then become an engineered solution. So what do we do? Again, in absence of any information, how do we build an answer that can hold water and provide value to a team? So what we're going to do in this demo is we're going to talk a bit about configurations of this heat pump water heater system. We'll then look at how that is configured in components in EnergyPlus. And then we're going to look at an example of those components in this medium office model. And we're going to then talk a bit about how we use our pre-sizing tool to build all those inputs. And then as a second video, an additional, I'll show you how you can add it to an internal zone instead of sourcing thermal heat from outside. I'll demonstrate how you could also put it in a room and what that looks like. Okay, so here's our heat pump water heater. And what I've done is in the middle, we have the outdoor compressor. It's heating a tank of water. Cold water's coming in from the street. There's generally then a mixing valve and it goes out to the building. This is diagrammatic. I actually don't think there is technically a mixing valve in the software, but there is certainly this pump in the configurations of the model, which may or may not actually be there in some designs. They may just use the pressure from the city to push water through the building. But what I've done is I've kind of broken out in these dashed gray boxes the components that EnergyPlus breaks out. So it breaks out the actual heat pump, and we'll look at some devices in a second, but that's where you can specify the compressor. There's a little tiny condenser water pump. There's a crankcase heater to keep the compressor happy. It then separates the evaporator fan that's moving heat across the coil. This is where you're pulling heat from the outdoor or a room if it's in a room. On the other side, we have the water tank, right? So it's a stratified tank. There's another mixed tank, but we're going to look at a stratified tank. This is where you would have your backup heating devices. You can have two different devices. You can specify the location of these. You can specify the capacity, when they turn on, a number of things. This is also where you have what it's called like parasitic losses. So when it's running, how much power is it losing? When it's off, how much power is it using? Sometimes that takes into account like pipe losses. Generally, the EnergyPlus manual kind of says like this is used for a lot of things. There is also like tank insulation as a separate input, and you can even say this tank is located in a room. So even if it's sourcing thermal heat over here from outside, you can still put the tank in a room and exchange heat in that little room. Okay, that's our kit. And so what we're going to look at is, let me rearrange these actually. Let's go to, where's my little diagram? Okay, well, yeah, so this is the kit of parts. This will work. So just from like a concept, heat pump water heaters can kind of be sized at two ends of the spectrum. Assume you know a lot about the system, how much water you need, the daily profile, the draw schedule is what they call it, but really the fractional schedule of how much hot water is used in a day. All that then compounded down. You can then use a sizing tool. This is the Eco Sizer. And essentially what this is showing is that like you could either buy a really small tank and a large heat pump, where that heat pump might need to run for a period of time to reheat that tank. Or you could buy a really small heat pump and a huge tank that's big enough for the peak load, and then you just trickle charge, right? So if you had to run that heat pump flat out the day before the peak for 24 hours, you would need a 400-gallon tank. But you bought a heat pump that's half the size. And that might be of interest, but this concept is what designers are grappling with, and something that would be a thought of a project. Like they would come and say like, we want to evaluate these types of configurations and sizes. But it's good to understand that concept, even if you're just the modeler. All right, so another way though is to just use the numbers from assumptions around hot water flow and some basic assumptions about how long we think that system should run to refill the tank with hot water. So this approach that we're going to look at in Excel is based on the peak flow. It's based on the daily schedule of fractional hours in a day, the draw schedule for hot water. We're going to make an assumption for how long we want that heat pump to run to recharge the tank. We're going to pick a water temperature. We're going to pick a delta T, a change in water temperatures that we're going to assume the system operates with. We're going to size the system for all these different devices, the heat pump itself, the backup heater, the crankcase, and just use some assumptions that can kind of relate, that will fully relate the capacity to our time goals, and then a backup power we'll pick based on like a fraction, and then some of these other ones we'll also pick based on the size of the system. All right, here, let's see. So we're going to start by looking at the flow of water from a model. We're then going to pick how long we want to, again, recharge the system. We're going to pick 6 hours. We're going to look at the daily heating we would need for that whole day. We're going to size the heat pump based on how long we want it to run. And then we're going to size these other devices. So I'm going to switch over shortly here, but the general workflow that we have is to make a model, build some zones, from there, determine how much water flow you might need and the draw schedules for those spaces. This could be done in a number of ways. In prototypes, this is even in Title 24, spaces are given a hot water allowance, and based on the type of space, they have a draw schedule. We're going to share some of those schedules, so if you really have no information, you could even use our little tool we've built to pull that info. We're then going to plug that into our pre-simulation sizing and input guide spreadsheet. It's one sheet with a bunch of questions and inputs and outputs. And then we're going to plug those numbers into EnergyPlus. All right, so that's what we're going to do in the next video. And I'm going to pause this here and start the next video. And with it, we're going to go over this EnergyPlus plumbing diagram and then look back and forth at how it's actually configured in the software.